Right, so if you look at this one, you're supposed to watch the video 24 and 25. And then I highlighted, today we are focusing on magnetic force. So from now on, try to write down magnetic force rather than magnetism, etc. Okay, so I will still tell you when magnetism is acceptable, when it is not so acceptable. Okay, what are the things that you should be, or what are the words that you should be using instead? Yeah, okay, I see. So Giselle, that's why all in term 2, right? Okay. All
For
right.
the rest are in term 1 already, except for science, because for my timetable there's very little science, so we have to always switch with math.
I see. Your school
And it's
focus
very
more on math.
difficult. Yeah, I don't know. It's
Okay.
very difficult, and then they always make mistakes on the timetable.
Oh, never mind lah. I think they will make it up to you. Okay? Don't worry. Now, if you look at my screen, can you see this particular mind map or flow chart? Okay, so we did magnets when? Which year? Okay, not talking about myself with you, but when you were in school studying for the past few years, right? When did you learn about magnets? Okay, all right. Some of you said P3, P3, P3. Anybody actually learn magnets only in P4? Yeah, there are some of you like Matthias. Avril also said the same thing. Now, if you are learning in P4, I think that's because the school that you're in, they adjusted the topics. You know that the current P3 and P4, right? They are following certain textbooks that is actually determined for them. So the school cannot choose topics that's supposed to be taught in P3 to be taught in P4 anymore. So they have their new textbook to use, not the ones that you're using. All right. So they also don't have to learn the topic on cells. Okay, you learn that in P5. They no longer need to learn that. The current P5 will be the last year learning cells. So the current P3, P4, when they move on to P5 next year, they don't do cells anymore. Very lucky, right?
Sorry, I cannot hear you.
Okay, you want to log out and log in again? I let you in. Maybe it's
My internet connection is unstable.
yours, huh?
Yeah, I could not hear you for like about 10 seconds. I cannot
Okay.
hear whatever you're saying.
Okay, what you need to do is you have to fix that. You might even need to get out, then come in again.
Okay.
Yeah, you want to try that? Yeah, so it's better. Okay, so the rest of you can see, let's move from the left-hand side, okay, and then we move to the right side. Timothy sells your favorite topic. You will learn it again in Sec 1, not to worry. Okay, learn it again in Sec 1, and it's going to be a lot more info than what you have learned in the P5. Okay, so we know magnets have two poles, North Pole and South Pole. Where are the North and South Pole? Someone tell me. Where are the North Pole and South Pole of a magnet? Okay, Giselle, you're back here. All right. Avril says it's actually at the sides. Then the Vinuli and Brian says at the end. Matthias says at the end. So at the two ends of the bar magnet. Let's say we are talking about bar magnets. Imagine this is what I'm holding, a bar magnet. So it's actually right at the two ends. When one is north, the other one will be south. Yes or no? Okay. What about those, have you all actually used the round ones? Okay. The circular ones, where do you think is actually the poles? For example, okay, I have this particular magnet that has this shape.
In the middle?
Yeah, okay, good. Drawing not so good, but it's fine. You can see. Okay, so how do you determine the sides now? How to have the North Pole and the South Pole? Front and back. How do you determine front and back? You mean here is front and then here is back?
No.
Okay. Then how do you determine the top and the bottom? Okay, so now you are talking about The round side, right? The round side. So either the top or the bottom. So when you are talking about, one side, the top side having north, then the bottom side must be south. Okay? Yeah. Giselle, I saw that you were trying to annotate also. Yeah, so it's actually at the sides, right? You're trying to point to that side. Good. Now, what other magnets have you come across? I think it's crucial that you are familiar.
Horseshoe magnet.
Yes, horseshoe magnet as well. Okay, good. Some of you are typing in also. Good, Avril. So horseshoe magnet is another one. How do you determine the north and south for the horseshoe? All right, so if I were to show you, okay, just now we talked about the disc, correct? Now we talk about the disc type. So this is the horseshoe. Then you have, still at the ends, either the north or the south. Brian, button magnet is similar to the disc type. Okay, so the button magnet is similar to this one. Okay, how about those ring magnets? Somebody mentioned ring magnet. What do you think?
The one is in the middle, the hole is in the middle.
The
The
hole
one
is
that is a
Okay, so you have the hole in the middle. How do you determine the north and south pole? Or where can you find the north and south pole?
top and bottom.
Top and bottom. Very
Oh.
good. Okay, now, because a few of you are trying to speak, so it's a little bit muffled. So I prefer all of you to type in the chat box. How about that? Okay, so I don't have to ask you all to repeat again, then we cannot hear each other, etc. I think it's easier that way. Okay, good. Yeah, Vinuli said she has a ring magnet that's stuck to the computer. Okay, good. The flat magnet. Yes, correct. Similar to the flat one, Giselle. Good. So let's go on to the next part here. It says when it comes to rest, it will lie in this north-south direction. Do you know how this is done? Do you still recall? Your teacher probably asked you to tie a string right in the center of the bar magnet, right? And then let it hang somewhere. Okay, and then it's going to stop moving at a certain direction. So that is how you can determine. Other than hanging on the string, did you do any experiment or have you come across any question that is similar? So let's see. Other than hanging on the string, what else have you come across? Nothing? You sure? What about a tub of water? A tub of water, maybe a piece of styrofoam floating, and then you leave the bar magnet on top of the styrofoam, and then it will move freely, and then definitely it will come to rest, right, at a certain time. Have you all seen that type of question before? Giselle, have you? You have, right? So be familiar with all this. It's not just about tying tying a string on the magnet.
And the pin, the one where you hang the magnet, and after that, then you put a lot of pins at the bottom. Then after
That
that,
one is to test for the strength of the magnet. Alright. Yeah, we are still at this particular part here. Okay, so we want to see that it comes to rest, right? So when freely suspended doesn't mean just tying with a string, It can also be the case where you have a tub of water and then you have maybe a piece of styrofoam magnet on a piece of styrofoam. So the styrofoam floats on the water, isn't it? On the water surface. Let it come to rest. It will definitely stop in the north-south direction also. All right. So next point here, we are going to the right-hand side. Okay, so magnets attract magnetic materials. It will attract another magnet when unlike poles. Okay, so this keyword here, unlike poles are facing each other. So they talk about the magnetic materials such as iron and steel. Do you have other examples that you can share? Do you have other examples that you can share other than iron and steel? We are doing revision of the P3 topic, yeah? Okay. Let's see. Kendrick, do you know of any other magnetic materials? And what about Jairus? Okay. Brian said metal. Tanmai said metal. Avril, you say copper.
We know
and-
what we call.
Type into the chat. Type into the chat. It's easier for us. So we have Avril saying copper and cobalt. Okay. Copper is not. Giselle is correct. Nickel. Then Vinuli says cobalt. So Avril, you got one right and one wrong. So cobalt is correct. And then we also have nickel. So there are actually 4 types here. Not all metals are magnetic material. Take note, okay? So if you are talking about things like copper, things like aluminum, you're all wrong. For metal, right, it is only iron, steel, cobalt, and nickel. Clear? So you have to remember. If you talk about all metals can do something, you should be referring to electrical conductors. So you are thinking about conductors of electricity, right? Then all metals are conductors of electricity. Okay, now talk about repulsion. When the magnet is facing another magnet such that their like poles are facing each other, there will be repulsion. So in your worksheet, I saw answers saying that, they repel because unlike poles are facing each other. This is an area that you need to be very careful about. Okay. Brian, brass doesn't attract, Okay, brass cannot be attracted to magnet. Copper. Okay, brass is actually copper and zinc. No. Okay, so it doesn't. So magnets are used in everyday objects such as compasses, magnetic chessboards, door stopper, okay, even in the refrigerator. Any question here? So far, okay? Yeah. So if you are thinking of copying this down, don't have to. Do you know you can download these notes after class or not? You all know, right? If you all don't know, let me guide you along. Okay, those who don't know how to download these notes, okay, let me know. All right. So second slide on the recap, magnetic materials can actually be magnetized using 2 methods. All right, you must have already done this before as well. Timothy, you put out your hand? No, huh? Okay, accident lah, no problem. Okay, so stroke method. Do you still recall you are supposed to, maybe have this particular, maybe iron bar laid down this way, and then you have this piece of magnet. Okay, how do you stroke this? There must be a certain action, isn't it? Okay, so you are supposed to stroke this in a fixed direction. Do you all recall? Okay, and then it has to be going from one, maybe left to right, and then left to right in the same direction. You can't go from left to right and then to left and then to right. It will not magnetize your iron bar. Okay, so you must always make sure you are doing the stroke method in the same direction consistently. From one end, okay, from this end, all right, to the other end. Please note this. This is crucial also, okay? Then what about the other one? Electrical method. If you still recall, there will be an electric circuit, right? Okay, so there is definitely this piece of, maybe this piece of iron bar once more, okay? And then you have the Okay, you have the wire that is